Hello, my name is Nathaniel Bellis, and I am the project lead of the Data Acquisition System for Industrial Machines Phase 3 project for Carrier. Our team was tasked with creating a control system device that is capable of long-term data acquisition. The device is in charge of recording data from sensors like thermistors and valves, as well as output control signals to devices like relays and stepper motors. The hardware is based on a plug-and-play PCB that allows for a Raspberry Pi to slot in and communicate with all inputs and outputs of the system. Screw terminals can be used to easily but securely connect the sensors and actuators. The inputs consist of 10 resistive, 2 DC voltage, 2 DC current, and 6 AC voltage, while the outputs consist of 10 DC voltage, 2 DC current, 6 digital relays, and 1 stepper motor. The inputs are fed into circuitry that converts it to something that is readable by the ADC and is sent to the Raspberry Pi over SPI. The Raspberry Pi then stores all the necessary information and makes control decisions about what the outputs should be. The outputs are then sent from the Raspberry Pi over I2C to the DAC, which feeds it into more circuitry that converts it to the required outputs. The software utilizes a series of open source services and microframeworks like Redis, Grafana, and Flask for data storage, graphing, and user interfaces respectively. As the inputs come in from the ADC, they are transformed into the proper units and then stored directly into the local Redis database as time series data. A local Grafana server continually pulls data from the Redis database and stores graphs of the data as panels. Once per second, the updated data is displayed on the GUI and stored for the Flask web server. The local web interface shows the most recent values for each input and output, as well as providing hardware status information. We have completed assembly of the prototype and done complete end-to-end testing of all modules within the device. A design utilizing the Raspberry Pi Compute module has been partially completed for even more modularity down the road. What remains to be done is complete testing of the system for at least 120 hours, as well as completing the documentation for both the hardware and the software. Once these tasks are complete, Carrier will be able to begin integrating our design into their industrial chillers. Thank you.